Now, this podcast is to show you how to do hypothesis tests for population mean. Now, we know when we have hypothesis test, first of all, we need to have null hypothesis H0, and then we will have alternative hypothesis HA. Then we need to calculate test statistic TS. And finally, we decide rejection regions. So the hypothesis test for population mean, the H0 can be mu population mean less than equal to m. M is a specific number. Or mu equal to m. Or mu greater than equal to m. Now, if null hypothesis is mu less than equal to m, then alternate hypothesis is mu greater than m. And then we will use right-tailed test. So if H0 is mu equal to m, then HA will be mu not equal to m. And in this case, we will use a two-tailed test. Now, if H0 is mu greater than equal to m, then HA will be mu less than m, and we will use left-tailed test. The next step, we want to compute test statistic. Test statistic, if our sample size n is large, we will use z-test. So z equal x bar minus mu minus m divided by sigma times square root n. Now, if sample size n is small, then we use a student t-test. So t will be x bar minus m over s times square root n. Now, small s is sample standard deviation. And finally, we want to calculate rejection regions. So we need to check z alpha. Z alpha, we can use Excel function z alpha equal NORM SIMV. Then you put significant label alpha, or sometimes we use alpha over 2 when you have two-tailed test to calculate z alpha. Now, if we have t-test, then t alpha will use equal TIMV. So if the test statistic z greater than critical value z alpha, then we reject H0. If z test statistic z absolute value greater than z alpha over 2, this is a case of two-tailed test, then we reject H0. Now, if z less than negative z alpha, then we reject H0. This is when we have left-tailed test. Now, here is a remark. For sample size n greater than equal to 30, and even sigma is unknown, we may replace sigma by s and proceed with z-test. Now, let's see the example. So now here is an example. Suppose the Miller Valley Brewery distributed beer in bottles labeled 32 ounce. The Bureau of Weight and Measures randomly select 50 of these bottles, measures their contents, and obtain a sample mean of 31.8 ounce and standard deviation of 0.5 ounce. Use alpha equals 0.01 significant labels. Test the Bureau's claim that the brewery is cheating customer. So cheating customer means the sample mean less than 32 ounce. So now we have our H0. H0 is mu population mean greater than or equal 32. The specific value M is 32. And alpha is 1%. Sample mean X bar is 31.8. And sample size N is 50. So H0 is mu greater than or equal to 32. So H1 is mu less than 32. So now we need to calculate test statistic. Test statistic is we can use the formula X bar minus M divided by standard deviation times square root 50. So we have negative 0.05657. Then we need to calculate critical region. So Z equal, we say this is Z alpha. This is left tail test. Z alpha equals NORM SIMV. You plug in alpha because this is left tail test, one tail test. So you get value negative 2.32635. So now what's the conclusion? Because test statistic is greater than critical value Z, or we can say test statistic is not in the rejection region. So we don't reject H0, and hence the brewery does not cheat consumers. Now be careful, rejection region, this Z in some textbook called the critical values.